16 is one of the harder ones. Getting this off the proportions worksheet. Watch carefully, you got to know how to do this factoring. And I'm going to go through it very quickly. We got a bunch of time, so hopefully we can do a bunch of problems, right? That's supposed to be a -2 up there. First thing we do, what I tell you to do anytime you have a binomial. Put parentheses around it, good. Jonathan, listen to me sometimes. So he listens all the time. He likes to act goofy sometimes, I think, don't he? We cross multiply. This one's sort of a tough one again. Anybody remember what are these called again? First and fourth terms are called the, starts with an E. Extremes. Good. Second and third terms are called the, starts with an M. Means. All right? Means. So extremes, means. What's 2 times -2? Now, most of the rest of them on this page, so that Dustin doesn't get so scared that he just quits. Most of the rest of them on this page aren't near as hard as this one. Because as soon as I see this, I know that I'm going to have to factor. Do you have to factor on most all of them? No, most of them are just cross multiply and solve. All right? So on this one, first thing you got to do, get rid of the parentheses. And most students don't like this kind of problem because you're going to get rid of the parentheses, and then when we get way down here, you're going to have to put it right back in the parentheses.
So you have to do that one thing, right?
You got to do, what's that one thing?
Arrow things, right?
Foil, right? Got to do foil. The reason we have to do all that is because what needs to be on this side over here? 0. Remember when we did the E-Day one? 0 has to be over here. You can't have that -4 over there to solve this. So we do, what's F stand for? First term's 3x times x. 3x squared, good. O stands for what? Outer. 3x times 2 gives you what? I stands for inner. What's -1 times x? And then L stands for last. What's -1 times 2? -2. Now I haven't finished out the problem yet because I want to do another step. And if you start doing this, start finding little tricks that make things easier on you, you won't be so scared of factoring or something, a harder problem like this. This -4 is messing us up, so it's got to jump over to the other side. Anytime you jump something over the equal sign, what happens to it? It changes the sign, right? So since this 4 was a negative, when it jumps over, it's going to become a, so I'm just going to go ahead and do that right now. Put a +4 over there. What's left on the right-hand side? That's what we wanted, right? That way we can make it a little easier. We don't have so many steps. Doesn't take quite so long. Now we got to collect like terms. What like terms do we have? Now is the 3x squared like terms with those other two? No, so it just stays the same. What's this give us? Be careful. +5x, right? Then you got these like terms. What's that give you? Now, remember when we wrote all that stuff up here, the steps, the other day for factoring? We had to draw the parentheses, and I probably said even Kenneth can draw the parentheses. I didn't say that. Something bad like that about you, did I, Kenneth? It was probably somebody else, wasn't it? Probably Grant, because I pick on him all the time. We draw the parentheses. We got to find the factors of the first term, which is 3x squared. What times what gives you 3x squared? We just got it, didn't we? Didn't we just multiply those together?
3x and x.
3x and x. That's the only thing, isn't it? That's the only pair of factors, and that's good when there's only one pair of factors, because then what do we know goes right here? 3x, and what goes right here? Then we got to find the factors of the third term, which is +2. And since that leading coefficient wasn't 1, we can't do that little trick where they got to add up to give you, where they have to add up to give you that 5. It doesn't work. So we just got to find all the factors of 2, plug them in here, check it and see if it works or not. Give me the factors of 2. 1 and 2. There's one more pair that everybody always forgets about. -1 and -2. -1 times -2, does that still give you a +2? Now, which ones do you think we're going to use if everything in here is positive? Probably the positive ones. That'd be a best bet, right? So we'll probably try them first. Now, does that mean I want to stick 1 right here and 2 right here? Could they be switched around? Yeah, and that's where you just gotta guess and check, see what works. So which one do you want me to put 1 here or 2 in the first one? 1. That means I put 2 in the second one. Now the way we check it is by doing FOIL again, but we actually just do the outer and inner. What's 3x times 2? 6x. What's 1 times x? What's 6x plus 1x give you? 7x. Is that what we had in the middle right here? So what's that tell us? We did it wrong. We got to switch them around. So tell me what to write here. 3x plus 2. X plus 1 equals. Are we finished? That's the factoring. Now we got to solve it. The way we solve it, taking 2 things, multiplying them together, and they equal 0. Then you know one of them has to be what? 0. So what's my first equation? All you do is you take this set of parentheses, set it equal to 0. And you take the second set of parentheses, set it equal to 0. How do I solve this second one? What's x equal? -1. How do I solve this one?
You put in -1.
-2. Now, and that's a bad thing, because everybody thinks when you solve for x, how many answers should you have? 1, because that's what you got used to in algebra. When you have a quadratic where it's got a squared term in it, guess how many answers you're always going to have? 2. Guess what would happen if I had an x cubed? Then you'd have 3 answers. What if you had x to the 10th? You'd have 10 different answers. Right? Yeah. You probably don't ever want to have that, do you? Do I want to change that to a decimal? Do I want to grab my calculator and divide it real quick? No, because -2/3 is going to come out to be 0.6666. We don't want that. Just leave it as a fraction. Those are our 2 answers. Got to be able to factor. I know we don't do a whole lot of it in here, but in Algebra 2, got to be able to do it. Give me some more. 17. 17.
If I would have picked 17, so I wanted to be like, really? Let's do something else, but no, someone else picks it.
Here we cross multiply. What's 5 times 20? 100. What's x times x? X squared. Remember, it's x squared, right? Now watch this one, because you could factor this one. We could move the 100 over here, and I'm going to do that here in a minute just to show you, because that's a special pattern that you should have learned in algebra. But the easier way is, what's the inverse or the opposite of squaring something? Taking the square root. Good. So you take the square root of this. What's the square root of x squared? X. Notice on this problem, we just got an x squared term. Over here, we had x term and an x squared term, so we couldn't do it this simple way. Right? So when you have an x and x squared, that makes it harder. You have to factor. We do the same thing the other side. What's the square root of 100? 10. Now, the bad thing is, what I just tell you a couple minutes ago about anytime you have, you should have had 2 answers. We only got 1. So apparently, we've missed something here. X equals 10 because 10 times 10 equals 100. What other number in our number system times itself gives you 100? Listen to me. Times itself. Don't nobody say 2 times 50. Negative 10. Very good. Negative 10 times negative 10 is what? Positive 100. Those are your 2 answers. Probably last year in algebra, you might have wrote it this way. Does anybody remember doing it that way? X equals plus or minus 10. That's the only thing you remember? The plus or minus? Now, if we would have done it a different way, we could have moved that 100 over to the other side, and it would have said x squared minus 100 equals 0. We could have factored it, just like we did on this one. What's the factors of x squared? X and x. What's the factors of negative 100? 10 and negative 10. Put in plus 10, minus 10. All right? What's the answer to this one going to be? What fits in here to make this parentheses 0? Negative 10. What fits in there to make that one 0? 10. So you could have done it the factoring way also. And that's a special pattern. It's called the difference of squares. When you have 2 perfect square things, terms, the difference of squares. What happens when what?
You only have like one like x plus the number.
So you don't have an x squared or anything?
No, like number 8, like.
So find me a problem and I'll do it.
It's number 8.
Number 8.
It's like it only has one of those things.
Makes it easier. What's the first thing I do on this? Jonathan, what's the first thing I do on this? I tried to give you an easy answer, make you look intelligent because you've been doing real well today, and you blow it. We cross multiply. What's 7 times 5? 35. On the other side, Dustin, when we do this, watch. You just write it down. 10 times b plus 5. We know Dustin, the only reason he's having problems with something like this, Dustin, do you like to write stuff out like I tell you to do? No. And that's where everybody's going to have problems with something like this. Write that out. Because now I guarantee Dustin can tell me what to do next.
Or you do those weird like.
Don't make me look stupid, Dustin.
Yeah. There you go.
You distribute. Everybody remembers distributing. 10 times b gives you 10b. 10 times 5 gives you 50. Now what do we do? Minus 50 on both sides. That gives you negative 15 over there, right? Somebody tell me if I do any math wrong. Then what do? Divide by 10. Michael, when you divide by 10, what do you actually do? Anytime you divide by 10, anybody, what's it actually doing? It's just moving the decimal over one place, all right? So if this was negative 15, where's the decimal in negative 15?
1.5.
So it's going to end up being negative 1.5. If you multiply by 10, what's it do? Moves the decimal the other way, right? So if we were multiplying 15 by 10, instead of being 15, it would be, you'd add a 0 and it'd be 150. Next question. Number 19. Be looking, try to find some other problems on here. I'm trying to move quickly. Tight end scored 6 touchdowns in 14 games. Find the ratio of touchdowns to, I'm not erasing the line, so you'll just have to deal with it. Touchdown to games. So all we're going to do is do a ratio. We don't have to set up a proportion or anything else on this one. How many touchdowns did this tight end score? 6. How many games? 14. That's our ratio. There's only one problem with it. What do you got to do to it? Reduce it. grab your calculator. All your calculators will do this. If you have the TI-30, you just hit 6, ABC button. Where's your calculator? So use it and do it. I taught you how to do it last time, right? 6, ABC button, 14. What's it give you? 3/7.
I don't know how to do that much. You said we got a case here or whatever.
You don't have an ABC button on there somewhere?
Different little button.
It's on here somewhere. It's probably there right there. Put in 6, go down, 14, hit enter. Next question.
I have a question.
Yep.
If it says like per game or like other stuff like that, you don't have to always back it to like one, like one.
You don't have to. Sometimes it's better to do it that way. If you're looking, if we just want a ratio, this is a ratio. But if we want, and we talked about this earlier this year, and I gotta remember the name of it. I can't remember the name of it. I don't know. It's got a special name when you reduce it down to 1. So if you wanted to know on this, you divide the top and the bottom by 3, and you'd end up with something like 1. So we know he's going to score 1 touchdown for every. Divide that, and you'd end up with what? Divide by 3, it'd be 2 1/3. So for every 2 1/3 games that they play, that person's going to score a touchdown. So if like in basketball, when you're dealing with points and you want to figure out points per game, you might want to go down to a 1 there or something.
We do 18.
18.
Okay, this can't be right. Oh, yeah.
When you're looking at stuff like in the grocery, you want to take it down to 1 ounce, and that's why they have a bunch of decimals. So if you look at a can of beans, and a can of beans is 10 ounces, but down below it'll say 1 ounce or 3.2 cents per 1 ounce. They take it all down to a 1 there. You ready to find me another one? We're probably going to skip over this packet here in a second. First thing I would do with this, you look at this 2/8. What do you notice about it? It could be reduced, couldn't it? I would probably reduce it down to 1/4. Is it going to be easier to multiply by 1 and 4 than by 2 and 8? Yeah. So if you can do that, do it. If it confuses you to do it, then don't do it. Jonathan, what's the next thing I do? Here, when I multiply, 1 times n minus 4 is just going to give me n minus 4. On the other side, I got 4 times n plus 4. What do I do next, Dustin?
You do the line arrows times thing.
You end up with 4n plus 16. Subtract n on both sides. End up with -4 equals 3n plus 16. I don't believe that anybody had trouble with this problem. I believe that people had trouble, whoever asked me to do it, had trouble because they got to this point and they seen this and they divided, and what's going to happen? It's not going to come out even, is it? Does everything have to come out even anymore?
No.
No. Divide both sides by 3. Is 3 going to go into 20 evenly? You know what I would do here? Leave it that way. No reason to change that to some crazy decimal. No reason to change it to a mixed number unless the problem says that you need a mixed number. Find me another problem.
22.
22?
Yeah.
22 in the major leagues. In Major League season, Sammy Sosa hit 49 home runs and 556 at bats. Find the ratio of home runs to at bats. What's going to go on top? 49, good. What goes on bottom? 556. Take your calculator, see if that'll reduce any. 49, ABC button, 556. 7/8. It won't reduce to that.
That's 49.
It doesn't reduce any?
No.
Alright, so that would be our answer. Now, what Jay Lynn was saying earlier, and I know a lot about baseball, I know a lot about baseball statistics, they would not tell you that Sammy Sosa hit 49 home runs for every 556 at bats. That makes absolutely no sense to whoever looks at it next. I have to look at it and see why you're getting some different
No,
answer.
I forgot to put the 6 in there.
Oh, did you?
My fault.
So what they would do here is they would divide this top by 49. If you divide the top by 49, guess what you got to do on bottom? Divide it by 49. What's 49 divided by 49? 1. Somebody help me out. What's 556 divided by 49? 11.3. What's that telling us? So every 11.3 times he's at bat, he's going to hit a home run. So if Sammy Sosa in this season hadn't hit a home run in his last 10 at bats, could I go to the bookie real quick and make a big bet and say, hey, he's going to hit a home run next? And they probably give me like 50 to 1 odds or something. Be a pretty good bet, right? Because he's due. Probably not really.
So you do the same thing for number 8, just like that.
Yep. Well, you could just stick that in the calculator and see if it'll reduce and just leave it that way. It won't, so you could just leave it that way. Well, I think. Hold on. No, it says girls to boys. What's 305? That's total students. You want boys on bottom. How would you find the boys? Minus it. Other questions, real quick. One more off this packet. None? 37? 37. Have the other packet out. We're moving on to it here in a second. 37. The ratio of the measures of the angles of a triangle are 4, 5, 6. Anytime, I told you on this back page, anytime you see something 4:5:6, what do you do with each one? Put an X with each one. So this angle here, it's not just 4, it's what? 4x. What's this angle? This angle? What equation can we set up? 4x plus 5x plus 6x. What is 4x plus 6x? 10 plus 5. And all that should equal what? 180. Somebody help me out and solve for x there. X equals 12. Is that our answer? They want each angle. What's 4 times 12? 48. 5 times 12? 60. 6 times 12? 72. Do you do the same thing on these top 3 up here that's dealing with perimeter? No. 3 sides of a triangle add up to 180, right? No. 34, I'll tell you how to set it up, but I'm not doing it.
What about even?
What do you do with that? 3x, 4x, and 6x, right? So 3x plus, are you writing any of this down? 3x plus 4x plus 6x should equal what? Not 180 this time. It's perimeter. 104. And then you solve that, and then you plug back in to find each side. Can't solve that?
I can solve it.
Well, then do it. Quit looking at me like I need to do it for you. Goodness. This worksheet, the proportions worksheet needs to be laid right here. Make sure your name's on it. The similar triangle. The similar triangles one. Hang on to till next time and grab this. Sorry, Jalen. This is your homework. Listen carefully. I'm trying to give some of you a chance to get your grade up. I'm trying to give you some of you a chance to get your grade up, but what's going to happen? This one, the one you're picking up here, and the similar triangle one will count as double grades on Tuesday when you come back.
Completion grade?
Does everybody understand that?
Yes, sir. I turned this in like, right on Monday.
Hang on. The other things, don't forget, shh, listen while you're doing this, put the proportions up there, grab the other one. So the things that are due next time, the 2 packets, and the test redo. Remember I said I'd collect it next week? That's due next class. No, I'll leave it. So, the other thing, the quiz is on Moodle. I went on Moodle yesterday and still seen. Is everybody listening? Because I have this bad feeling Tristan's going to take zeros on these. Those quizzes on Moodle, they close today. If you don't get on there and do them, they go down to zeros. Why? They're not that difficult, are they?
Super easy.
I don't know. Get on there and do it.
I'm pretty sure I had one. I'm gonna turn it up.
Both worksheets due, both packets due next time. They all deal with proportions. What 3 times 4 is? 16?
It's clearly 2.
Problem 16, everybody should be following along. I'm going to do this one real quickly. This is one that deals with factoring. You got to watch, you got to know how to do this factoring.
Okay, I know we're working on the proportions packet, but we have 2 other packets.
You had one other packet, and then you had like the E-days too.
Yeah. Which one?
This is the one we're working on right now.
I know that.
And then the other one's the similar triangles one. Similar triangles, hold that up for everybody, Emily. So that's the other one that we're going to, yes, you're turning them in.
Both of them?
Probably. Depends on how well, if, right now, yes, because everybody's back here talking and stuff while we're supposed to be up here working. He would probably know that if he wasn't talking to us. On this, first thing you do, doesn't need to be talking unless you're answering my questions. If you don't need this problem, then go on and work a different problem. That's fine. Put parentheses around each of those. When we cross multiply, what are these 2 called again? The first and the fourth terms are called the what? Extremes. The other 2 are called the means. Good. We write this. This is probably the hardest problem on the whole packet, just because this is the one that most of you would do about halfway through and then probably give up on. What's 2 times negative 2?
-4.
Now, the reason that most of you would give up on this, we just done a bunch of these on that one E-Day packet, right? Where you have to factor then solve, or on the E-Day worksheet. Well, the bad thing is, what do you need to have over here? 0. You can't solve it if it's got a -4 over there. So what we got to do here is we got to FOIL all this out, move that -4 over to this side, put it all back together, and then factor it again. Set it up parentheses.
That's a header.
So what we're going to do first, FOIL, first terms. 3x times x gives you what? O stands for what? Outer, outside. 3x times 2 is 6x, good. I stands for what? The inner. -1 times x is, and then L stands for the last term in each one. -1 times 2 is what? -2. Now I'm not going to put the equals -4 yet, because a little trick here to make this a little shorter so that Holly does have enough room. We're going to end up moving that -4 over to the other side at some point, right? We have to. That's the whole point of doing this. Well, when it jumps over that equal sign, what's that -4 going to become? It's going to turn to a positive. So all I'm going to do right now is go ahead and make it a positive, put it on that side, and put 0 on the other side. That way we don't have 2 separate steps writing all that long stuff out. What's the next thing? Like terms. 3x squared, is that a like term with anything?
No.
No. So it just stays 3x squared. 6x and a -1x give you what? Those are done. A -2 and a +4 give you what? Now it looks like something that was on the E-Day packet, right? Except for, instead of a 1 here, it's got a 3, and that makes this harder. Right? Remember we said that? All of them on the E-Days were 1s. This one's a 3, that makes it a whole lot more difficult. First part, same steps. First part, draw your parentheses. I said the other day that even Jordan can draw the parentheses, right?
Yes.
We didn't say that. I remember who I made fun of. It wasn't you that time.
It was, no.
What are the factors of 3x squared? Factors of 3x squared. What did we multiply together to give you 3x squared? 3x and x. Those are the only factors. So what goes here? 3x. What goes here? So that's pretty easy. Because it didn't have more than one pair of factors, so couldn't be anything else. What's the other number we got to find the factors of? Remember, it's the third term. What's the third term? 2. Positive 2. Bad thing here, the other time we said multiply together, give you positive 2, add together to give you positive 5. That doesn't work anymore because of that 3 out in front there. All right, so you just got to find all the factors of positive 2, stick them in here, hope it's right, check it. If it's not right, you go back and you start all over again. What are factors of positive 2? 1 and 2, 2 and 1. There's 2 others. Negative 2 and negative 1, or negative 1, negative 2, right? Which one of those do we want to pick?
First one.
The first one? Everybody agree with Jacob? We know it's got to be positive, so it's probably not either one of these two, right? So we've cut Jacob's chances down to being correct and you guys not being mad at him because taking up extra time in half. Now what? What do we stick in here? Plus 2, plus 1. Just because Jacob said the first one, does that mean it's right? No. We got to check it. How do we check it? How did we check it last time? Gotta go back and use FOIL, only this time you only need the outer and the inner. Outer terms, 3x times 1 is what? Inner terms, 2 times x. Jordan ought to be answering every one of these questions. What's 3x and 2x give us? 5x, is that what we had in the middle? So are we right? Are we finished? No, we factored it, now we gotta solve it. Right? To solve it, we know that this times this gives us 0. So what's our 2 equations that we can set up? X plus 1 equals 0, or 3x plus 2. You just take whatever's in the parentheses there and set them up equal to 0. Are those easy to solve? Yeah. What's this one give us? X equals what?
6.
What do you do to solve this one? Subtract 1. I thought we could do that one without doing that. X equals negative 1. That's one of our answers. How do we solve this one? These are easy equations, right? These are what you did like the first day of algebra last year. 3x equals negative 2. Then what? Divide by 3. Is 3 going to go into 2 evenly? So do you grab your calculator and divide it? No, just leave it as a fraction. Negative 2/3. Those are your 2 answers. Next question. No others? Go to the other packet? Which one? 19. Some of you better speak up because we're going to go to the other packet, and if you don't have some of them done, you're going to be out of luck. 19. A tight end scored 6 touchdowns in 14 games. Find the ratio of touchdowns to games. How many touchdowns did this tight end score? So what's going to go on top? 6. How many games? 14. Now you grab your calculator, and you punch in 6, ABC button, 14, enter, and that gives you the fraction reduced. All right? Some of you that's got a TI-83 or TI-84, what you punch in is this, parenthesis, 6 divided by 14, close the parenthesis. So it ends up looking like this if you have a TI-83 or 84. And then you hit the math button. And what's it say right there as soon as you hit the math button? Frac, which is a fraction. So you hit enter or equals. And then it looks like this on your calculator screen. All right, so it looks like that. Then you hit enter again. What's it give you? 3 sevens.
But it asks you how many per game. Yeah, you.
Oh, did it say per game?
Yes, so you want to say equal to 1.
All right, so let's go back. I thought it just said a ratio. I didn't read the whole problem.
It says ratio of touchdowns per game. Per.
So touchdowns per game. Let me read it. Ratio of touchdowns per. Well, still, that would be fine. All right. Now the other thing you could do if you want just one game down here, what do you got to do this 7 to get it to be one game? Divide by 7. So you divide that by 7. What's 7 divided by 7? 1. What do you got to do on top then?
3 divided by 7.
3 divided by 7. What's that give you? 0.43. So how many touchdowns do we expect that person to score each game? 0.43, about a half of a touchdown. So if they didn't score a touchdown this Friday, what would we expect next Friday? That they're probably going to score one, right?
They scored 6 in one game.
Well, they very well could have, and then didn't score any the rest of the time. It'd be like you on the basketball court, right? Like 6 points in one game and then nothing the next. Other questions off this packet?
I saw you there.
I wouldn't be hating if it wasn't for the fact that he does the same thing that every other student I see go through National Trail does. Bring the ball down, you drive to the basket, and that's great. Why do you have to go all the way in for a layup? Is there a reason to go all the way to the basket?
So you can make it easier.
No. It's not an easier shot because about half the time you're throwing up some stupid shot or getting it blocked and it doesn't do any good. Right? Am I wrong? So what should you do? If the basket's that chair right there and I'm driving in and I know I'm only 6 foot tall,
Float.
Pull up.
pull up. Thank you. Pull up and shoot a 5-footer.
I can't.
Start doing that. Every year it's the same crap. Teach or coach it. I don't like coaching basketball
You get too frustrated.
then I would go out there with Jacob and I'd be thinking about what I had in geometry class that day when he was staring off into space and
You start telling me angles to shoot the
I
basket.
no, I'd start telling you angles to run suicide. That's what I do. 'Cause you've
You
got
get,
'em on
I feel like
toes.
you'd be a very angry coach.
Only a certain people. We got the few favorite kids, dude.
I would take his class.
Yeah, they said that didn't take
I'm
it
telling you, I don't like any of you any more than any of the rest of you. It's all the same.
You hate us all.
Huh?
You hate us all.
I don't hate y'all. I don't like y'all either. Ain't got nothing to do with anything like. Next question. 37. 37. She's trying to. Sorry, Brooke. Being a knucklehead. 4 to 5 to 6. As soon as you see something set up that way, what do we say to do? Put an X with each one. You got to remember this. So Jordan and Joel might want to listen right here so that they understand this. 4, 5, and 6. And we're dealing with the angles this time. Does that mean this angle is 4? No, it means this angle is 4x, this angle is. 5x, this angle is. 6x. What equation can we set up?
4x plus 5x plus 6x, which is 180.
Now, I'm not gonna solve that, somebody can solve it, and we'll come back to it here in a second, tell me what x is, and we'll go from there. X is 12. Now, what if you go back up to the ones up here that are dealing with the sides of the triangle? Is that gonna be the same setup?
Set them equal to the number.
Set them equal to whatever number they give you there, because then you're dealing with perimeter, not 180 degrees, which is only for angles. What do we do once we know x is 12 on this?
Plug it in all.
Plug it in. What's 4 times 12? 48 degrees. That's one of the angles. What's 5 times 12?
60.
That's another angle.
72.
72. Could we check our answer to make sure we're right? Yeah, they should all add up to be 180. You could go back and check to make sure you did everything right. Is it right? Other questions off the proportions packet?
No.
Got these? What is it? Huh? That's the one we're on now, the proportion. Other questions off the proportions? All right, other packet, questions? Everybody look up here if you're not sure which packet we're on. Number 9. Problem number 9, if Pentagon JKLMN is similar to the other pentagon, what is the measure of angle X? So they give us this. Got this pentagon. This is 60 degrees. That's 150 degrees. They give you this one. My pictures don't look so good, but we want to find that angle right there. They tell us JKLMN similar to VWXYZ. They just had to make it harder on me, so I had to write more. And let's label this first one. LK, those are really the only two angles we care about because the only ones we have numbers for, right? So L matches up with which angle in the other one? X. Is that what we're looking for? Yeah. Well, what do you know? If these two are similar, what do you know about their angles? They're the same. They're exactly the same. They're not proportional to each other. They're exactly the same. So if this angle's 60, what's this angle?
60.
60 degrees. That's your answer. Somebody tell me what that angle right there is. 150. Next question. Number 6. All right, with some of the tests, like the park test, and when you start to take different tests, I know on the OGT I've seen stupid stuff like this. What do you think this circle and this circle tell you about those two angles? They're the same angles. We always use the little arcs, right? Some other book might use smiley faces and put in there. They might use pictures of little dogs. They could use anything. As long as the things match up, you know that they're congruent. All right? So when you see something different, it's still the same idea. It's still telling you that those are congruent. So we got those two triangles, and since this angle is congruent to that angle, this angle is congruent to that angle, what can you tell me about those two triangles? They are similar to each other. So they're similar to each other. First thing they want is a scale factor. To find the scale factor, you find one side in the first triangle and compare it to the same, or compare it to the side in the second triangle. So you just set up a ratio. So you're going to have a ratio here. Now here's where you got to be careful. Pick me a side in the first triangle. 20. So if we pick 20, What side does 20 match up to over here in this one? You got to be careful, right? Because this triangle has to be sort of flipped over, doesn't it? Or like, not flipped over, I guess, sort of spun around. Because this is going to actually go up here. This is going to go over here. And this one's got to come down to here. So you got to spin it around to match it up. So it matches up to 5. Now, whenever you're doing a scale factor, if I'm doing a model joule, is it going to say the scale factor of the model is 20 over 5? It's going to reduce it down, isn't it? So what's that reduced to? 4 over 1. That's your scale factor. So that means if I'm right here on this corner in this triangle, and I walk 4 steps, Emily G's on this corner of this triangle, how many steps does she have to walk to stay caught up to me? 1.
You're the nut in
All right. So that's our scale factor. Now we set up a proportion. Well, when you set up a proportion, you can use that scale factor. Instead of putting 20 over 5 back in here, which you could do, is 4 over 1 going to make it easier? Yeah. So 4 over 1 compares to what? 16 over x. Cross multiply, what's 4 times x? 16 times 1? What's x equal? Ah, got too much. So x equals 4. X equals 4 and the scale factor was 4 to 1.
On proportions, do you mind if we do like this? When I set them up, I just do, I do the same thing, I just write it out differently.
That's probably all right.
I just, like, it doesn't show as much, but it makes more sense to me the other way.
Probably all right. Other questions? No others?
Wait.
17. We might not get finished with it, but we'll set up the proportion at least. On 17, pick me a side, Malachi, in the first triangle, the top triangle. 5x plus 11. What's that going to match up to in the second triangle? 18. Equals, don't go anywhere. How about the other one? What's next? 88 over what? That's right. No, that's 24. Before you go, listen carefully. The proportions worksheet. The proportions worksheet must be laying on that desk right there. Point at it. Austin. Must be laying right there on all 17. 17. No, I will not talk over anybody because I do not, my head's pounding. So you got to really be focused. If you already got 17, then work on a different problem. 2 different ways you could do this problem. We cross multiply first. What are these called again? Extreme is good. 5 times 20 is what? Be careful here. What's x times x?
X squared.
What's the inverse of squaring something?
Divide.
Not squaring it? No.
Dividing it.
No, not dividing by 2.
Times
Dividing, the inverse of dividing is what? Multiplying, right? So that can't be the inverse of 2 different things.
it would just be 2x.
Dom's pointing at this thing right here. What's that called?
Oh, square root.
Square root.
Oh, yeah.
So you want to take the square root of this side? What's the square root of x squared? What times itself gives you x squared?
X.
So that just comes out to be x. You want to take the square root of this side? 10. That's wrong.
Oh, yeah.
Because,
Why did we do it?
are you going to listen? Or are you going to interrupt me? Anytime you have a squared term, you should have learned in algebra last year, anytime you have a squared term, how many answers should you have? 2. How many answers do we have?
1.
What's the other answer?
0.
You got 10 times 10 gave you 100. What other number in our number system gives you 100? Now, let me say it before Noah upsets me and says something like 50 times 2, because that's, we want some number times itself that gives you 100.
10.
We already got 10.
100 times itself.
100 times itself is like 10,000. That's not times itself then, Noah.
It'd be 10 again.
10 again, what do you mean?
Well, if x times x is x squared,
We already got that.
well,
Negative 10 times negative.
always opposite.
Well, she can't help it, she's smarter than the rest of you.
On some subjects. She thought we would have school on Saturday.
You probably, last year in algebra, you probably wrote it like this. Does anybody remember writing your answers like that?
Yeah.
With the plus or minus?
Yeah.
You don't remember that?
I do.
We did that in here.
Last year in algebra. Now, the other way you could have done this, watch. Because you've got to know how to factor. To factor this, remember we did this on one of the E-days, right? Where we went through all the factoring. Can we have that 100 over here?
Yeah.
No, what do you need to have over there?
1. Or 0.
0. So if we move everything to one side, and I'm going to do this, if I move that 100 to that side, it'd be minus 100, right? But then, could I move all that over here to the left side and put the 0 on the right side? Does that change anything?
Yeah.
No. So we have this. We set up our 2 parentheses. This is actually a special pattern. It's called the difference of squares pattern. What's x squared? Remember you had to find the factors of the first term. What's that break into? So that goes here, that goes there. That was the E-day stuff, right? Then you got to find the factors of this.
10, negative
10, negative 10, and they should add up to give you the middle term. Well, what was the middle term?
10.
0. Does 10 and negative 10 add up to be 0? Now we solve each of those. What's going to make this one here 0?
You subtract 10.
All right, so x would equal negative 10. What would make this one 0? X would equal positive 10. 2 different ways you could do it.
Now this wouldn't work if it was like equals like 3 or 4.
No, because then it wouldn't be difference squared.
Easier to learn.
Next question. Just collect them.
18. 18.
24. 24. Sides of a triangle are 3, 4, and 5. Remember that triangle, 3, 4, 5? That's a very important triangle in the world. 3, 4, 5. Find the scale factor of the longest side. This is the part that kills me. I was helping somebody in intervention. If you read through this and you write it down like I'm doing right now, these problems are easy. We want to compare the longest side to what?
Short.
So if I write that down right like that, nobody has any trouble with it. What goes on top here then?
5.
What goes on bottom?
3.
That's your answer. They just wanted that scale factor, that ratio. So that means for every 5 inches on the long side, there's how many inches on the short side? 3. So if the long side was 10 units long, how long would the short side be? 6 units long. All right? Next question.
18.
Whoa. You just said it at the same time, kind of.
Whoa. That'd be crazy.
I know.
What's the first thing you do with these binomials? Now, the other thing I would do on this problem, because I hate multiplying things that are too big, 2/8. You could reduce that down to 1/4. If you can make it easier on yourself by reducing a fraction, reduce it. It's gonna make everything a whole lot easier. That way maybe you don't have to grab your calculator. We cross multiply, especially on something like this. What's 1 times that whole thing gonna give you?
1 n minus 4. Or n, yeah.
Just n minus 4, right? Now on the other side, we actually do this. What are you gonna do next? 4n plus 16 equals n minus 4 still. Now what?
Add n. Or, no. Subtract. Or subtract. I saw the negative sign, or the minus sign.
Subtract n, that leaves us with negative 4 equals, what's 4n minus n? 3n. Still plus 16, now what?
I'm paying attention.
No, you're not.
Yeah, I am.
Only when I look at you.
Exactly. I'm paying attention, because I know you're looking.
I'm gonna leave you right up here all by yourself,
I'm paying attention.
so you better be focused.
Negative 1.
Equals 3n, right? I'm gonna rewrite this up here. Negative 20 equals 3n. Now what? Divide by 3. Is 3 gonna go into negative 20 evenly?
Negative 6.6.
Is that what we want? I was hoping Isaac wouldn't even say something like that. Is there any reason to do that division if it's not gonna go in there evenly? Just leave it that way. Why grab your calculator and do extra work? Leave it as a improper fraction as long as it's reduced down. You might check on your calculator
Can you do the
with your ABC button and see if it would reduce. Now, do I really care if it's a mixed number or not? No, leave it as an improper fraction. You could change it to a mixed number if you wanted, but that's sort of silly. Doesn't help anything. Helped your 4th grade teacher when you were there, because she told you you had to always do that. 33?
This is the
Yeah.
33. Scalable map indicates that 1 inch equals 4 miles. If 2 towns are 3.5 inches apart on the map, what is the actual distance between the 2 towns? What's our first ratio that they tell us? 1 inch compares to 4 miles, right? What's the next number they tell us? 3.5, right? That's not 2. Does the 2 towns being, does that mean anything really to the problem? No, you got 2 towns, you don't really need the 2, right? The 3.5 means something. Where's it gonna go, top or bottom?
Top.
How come top?
It's in inches.
It's in inches. And X on bottom, I'm probably not gonna use X. Let's use what? Maybe M for, you could have used D for distance, M for miles, something that makes sense to the problem, right? Cross multiply, what's 1 times M? That's real hard. 4 times 3.5. What?
He heard you.
14.
So what's 14?
X.
What's that mean? Somebody explain the answer to me.
The distance for 3.5 inches. and
14
equals
inches?
14 miles.
The 2 towns are 14 miles apart. Next question.
22.
Wait, on those kind of questions, can you just multiply, that one it doesn't make any difference. Can you just multiply like these 2 numbers and just divide?
Isn't that what we just did?
Yeah, but some of them turn out longer when you do that. Like when you show your work like that, it takes longer.
How do you multiply and you divide?
Yeah, well, if you do the variable.
And if you do it the way you're saying first I multiply,
No, I mean the other ones first.
then I divide. How are you doing any less steps than what we just did there?
Because she's a genius.
Apparently, because I'm not seeing it. Because over here, what did I do? I multiplied, and then what did I do? I divided.
a different way, shorter.
Albert Allison.
I don't know how it can be shorter. If you multiply and you divide, and I multiply and I divide, how can it be shorter? Now, if I multiplied, then added, then divided, then multiplied again, and you just multiplied and divided, yeah, that would be shorter.
Because one of them has a variable and one of them doesn't.
She's Albert Allison.
So I guess, yes, it was shorter because you didn't have to write an X. So those two little marks there made it a whole bunch shorter. Which one did you guys say?
She said 22.
In 2002 Major League Baseball season, Sammy Sosa hit 49 home runs and was at bat 556 times. Find the ratio of, what's going to go on top? Ratio of home runs to at bats, right? Well, how many home runs do you have?
49.
So that goes on top, what goes on bottom?
556.
Grab your calculator. You got a TI-30 calculator. You use the ABC button on it. If
You
you
never
got
did show me where that is.
one of the big calculators,
It stays the same on his. Whoa,
Page can't even
Isaac.
find it.
Oh my god. Mind blowing.
It was. Did you hear it? You're like,
I heard it, but it's not what I
it's,
had to think of it.
it's,
too.
it's,
Oh,
That's
see?
the same exact
It's that little
time.
button right there.
That's
It's-
the-
it's-
that's the
the
word.
words are the same exact
It's
time.
caveman. That's what it is.
You're the count the words.
so it stayed the same, right? So that would be your answer, and that's fine, I would accept that answer. But if you were actually doing something that you want somebody to understand, is that going to make any sense to them? Does it help to tell anybody that, yeah, Sosa batted 556 times last year and he hit 49 home runs? No, so what they actually do, and this was a big thing back when Sammy Sosa and Mark McGwire were playing baseball, is they would tell it as a ratio with the colon in it, right? And what you would want to do on this, instead of having 49 on top, you'd want to have 1 on top. How would we make 49 into 1? And don't say subtract 48. Divide by 49, thank you. If you divide the top by 49, guess what you're going to do on the bottom? Divide by 49. Somebody help me out. And it's not going to come out even, so this time I won't yell at you for giving me a decimal. 11.4.
There it is.
So, what are they saying when they say this?
Every 11 bats, he had one home run.
So, if he bats 11 times, we expect that he's going to hit at least 1 home run. All right? If you go to the grocery store and you look on the little tags in the grocery store and it says something like this, 1 ounce, colon, 23 cents. What's that telling you? Every ounce of whatever that item is costing 23 cents.
A lot of people don't understand personality. They'll look at it and they just don't buy it because they don't understand it.
Yeah, and you see, especially with stuff like peanut butter,
Yeah.
peanut butter and laundry detergent are real good things that everybody, thinks, okay, I'm going to buy the bigger jar and it's going to be a lot better price. You go, next time you go to the store, look at the bigger jars of peanut butter and compare them to the smaller jars of peanut butter. Usually if you buy 4 of these smaller jars, you're actually getting a better price than that one bigger jar. Same thing with laundry detergent. But a lot, like Noah was saying, a lot of people aren't smart enough to look at it, so
They just go bigger.
yeah. All the bigger ones gotta be cheaper, right? Everybody thinks the more you buy, it's gotta be cheaper.
Like my mom the other day, she put my grandpa's strawberry orders on hers, and instead of ordering 1 full flat, she ordered 2 half flats.
Yeah, that didn't make
Exactly.
sense.
You paid $2 extra.
Yeah,
I
because
know,
the
like,
full
there you
flats
go.
are $40 and half flat.
Other questions off this page, or off this
Our
paper?
half flats 12.
37?
12.
37. This might be the last one off this one because I'm about tired of this worksheet. Ratio of the measures of the angles of a triangle. Michael, we know that the angles of a triangle always add up to be 180, right? Yeah? Is he right? Yeah, the angles do. What don't add up to be 180? The sides, thank you. What did I tell you to do with each one of these numbers? Put an X with it. So Instead of just this angle being 4, what's it gonna be?
4x.
4x, this angle? This angle? What's our equation gonna be?
4x plus 5x plus 6x equals 180.
Yeah, I wasn't done yet. Wait, right.
If somebody solves for x for me here in a second, I'll do one more problem while they're solving for x. Somebody got one more off of this one that they want to see?
Yeah, 30.
30? Problem 30, hang on to that thought, Dom. Problem 30 says, in a certain desert environment, there are a lot of small rodents. This will be my classroom. There also happen to be a lot of snakes that feed on the rodents. The ratio of rodents to rodent-eating snakes is 13 to 4, or 13 to 3, sorry. There are 4,000 laid on my picture. There are 4,000 snakes in the area. About how many rodents are there? What's the first ratio that they give us?
Rodent to rodent.
13 to 3. What's the 13 stand for? Rodents. What's the 3 stand for? Snakes. Now what? 4,000 snakes. Where's that going to go? What's going to go on top? Maybe R, X, it doesn't matter really, but now what do we do?
Multiply and divide.
Cross multiply, you get 3R. Somebody help me out. Now what? Notice, before you give me an answer, read the question again, just the question part.
How many rodents are there?
What's the key word there?
About.
About, so
Round.
round it to the nearest rodent. Dom said we had 12 over here on this one. Is that our answer?
No, you have to
No.
plug it into the x's.
Alright, you gotta plug in 12 right here. What's 4 times 12? 48, so one of the angles is 48 degrees. Plug in 12 right there. 5 times 12 is 60 degrees. Plug in 12 right there. 72 degrees.
I got a question for the number 30.
Yep.
If we did put like the little squiggle equal, does that change anything?
What's that little squiggle mean again?
About.
Approximately.
Wait, were you calling us rodents? No.
He's like, yeah, because
He
like
said
sounds like my
classroom
classroom.
is kinda like that.
He did?
Yeah.
I'll try.
Is he meaning us? I thought you had snakes or something.
Oh my god.
Mr.
Wow.
Wow.
Come on.
I take back the genius aspect.
The other one. We got about 10 minutes. I'll work problems off of the similar triangles. I can find mine. This one here.
Hey, Mr. Chairman, sorry, would you like to turn these?
Not yet. Here in a minute we will. Which one? 4. Problem 4.
Similar triangles were key. Maybe, I don't know.
This is the one we're on. If you're looking up here.
No, you didn't.
First thing they want us to find is the scale factor. They want you to find the scale factor. That's probably the key in all this. You've got to be able to find the scale factor. I forgot to put these in here. I actually ran this certain worksheet off because I know that you got like the OGT test or the PARC test and all that stuff coming up. We always, in this class, how would I show that those two angles are congruent?
You mark it like
With the arcs, right?
that? Yeah.
Other books use different things. So what's that tell us about these two angles right here? They're congruent. As long as they're marked the same, that means that they're congruent. All right? It could be anything. They could use any kind of symbol in there to show that. So that's part of the reason I wanted to make sure we got to some of these, because I know on the OGT test, they use some crazy stuff on there sometimes and I haven't really seen the park test, but they may do the same thing. Scale factor. With the scale factor, all you do, pick a side in one triangle, pick a side that it matches up to in the other triangle, and write a ratio. We want the ones that we know a number for both of them. So which two are going to match up?
6 and 4 point.
6 over 4.5. Now, on your calculator, you grab your calculator and you use the ABC button, even though this one probably won't work. If somebody's got a TI 83 or 84, it might, if you do it.
3/4.
I think you did it backwards.
Yeah.
Punch it in, using the ABC button, what's it come out to be?
It stands there,
It says error.
yeah.
Some of them say that because some of them, the TI 30s, don't like the decimal in the fraction. All right?
It still says it that way too.
Let's do it this way then. What could we do to get rid of that decimal? Times it by 10. If you times the bottom by 10, what do you got to do to the top? Now this is a lot of extra work that I'm hoping you can get away from after a while. You got 60 over 45. Now try that on your calculator.
1 1/3.
The problem with that is, that's what your calculator probably says, we didn't want a mixed number, did we? So you got 1 1/3. Well, we need to write that back as a fraction, so it's still a ratio. What's 1 times 3? Plus 1? So what's the scale factor? 4 to 3. So for every 4 parts in this triangle, there's how many parts in this triangle?
3.
Everybody understand that? So if I walk 4 steps right here, how many steps down here is it going to take me to walk the same on the triangle? 3. Okay, 4 to 3. Now, if you're having trouble with stuff like this, then when you go to do a scale factor, instead of doing what we did here and putting 6 over 4.5, so that you can use your calculator, what would help a lot, always put the smaller number on top and the bigger number on bottom. Then your calculator will help a little more. Now, does that always work? No, because sometimes they actually want you to compare them a certain way. So you can't always do that. Now we go to set up. So that's one of our answers. Now we got to find x. What proportion can we set up to find x? 6 over 4.5. X over 6. Cross multiply. 6 times 6 is 4.5 times x. Divide both sides by 4.5. Everybody agree with 8? So x equals 8. Other questions? Yeah, I looked at them all.
Well.
I gave a bunch of people zeros. Right, Michael? Is that what sense it is? 12?
I was going to be stuck in a
Yeah, because Isaac and Michael sounds exactly alike.
Do you not know that my first name is Michael?
No, it isn't.
Yeah,
Oh
it
my
really
God.
is. His real name's Michael.
No, you said it was Ethan.
Oh my
God.
How long have you been here? She doesn't. I walked in the freaking driver's ed and she was like, I know you. Did you go to Dixie? I'm like, no, we go to train. It's like, oh, you look different. Like, do I? Like, it's only been how long?
All right, looking at this one. Are these two triangles similar to each other?
Yeah.
Yeah.
We got a pair of angles. Is that enough?
No.
What else do you need?
Another angle.
So, do we have another pair of angles?
It says it.
So are they similar to each other? Yeah. Now you got to be careful when you set up this proportion for this. You got to make sure you match them up right. Pick me a number in this smaller triangle on top.
9.
What's it gonna match up to in the other triangle?
19.8.
So that is pretty easy, right? Pick me another number in the
5.
triangle on top.
5.
5. What's it match up to in the other triangle?
11.
Is that gonna help us any?
No.
No, we're looking for X.
6 and X.
So you guys made me write all that for nothing.
9 and
Now what?
My bad.
9 and 19.
9 and 19.8, we can still use that, right?
And 6 and X.
6 and X. This triangle has to sort of be spun around to match up correctly, right? Now, I probably wouldn't use the 19.8. Could we have just as easily said 5 over 11 equals 6 over X?
Yeah.
Is that easier multiplication? Yeah, 5 times X is 5X. 6 times 11 is 66. Now what? Divide by 5. You can give me a decimal answer this time because did we start off with decimals in the problem? And 5 is going to come out nice and even when it does that. What is it? 13.2. Let's talk a little about decimals here real quick. If you're dividing by 3, is that going to give you a nice answer?
Depends on what you divide.
Well, yeah, if it comes out even, then it's a nice answer. Is it normally going to give you a nice answer?
No.
No. If you're dividing by 6, is it going to give you a nice answer? Not usually. If you're dividing by 9, is it going to give you a nice answer?
No.
No.
Factors.
3.
Stuff like 2, 4, those are going to come out nice.
Yeah.
Yeah.
Dividing by 5.
No.
Sometimes
Alright,
they
well.
Yeah, it's usually going to go out one decimal place is going to be it, isn't it?
Yeah.
It's going to be like 0.2, 0.4, 0.6, 0.8. All right? Back to 9. If you're dividing by 9, your answer is always going to look like this. Anybody know what 1 over 9 is?
1 point
No,
something.
it's
Anybody know what 2 over 9 is?
2, 2, 2, 2, 2.
0.222. How about 3 over 9?
3,
3, 3, 3, 3, 3, so on and so on. Before you go, this packet laying up here. That's your assignment. Lay the proportions packet next to it. Not the other one, not the similar triangles. Listen carefully. Next class, when I see you guys on Tuesday, the similar triangles packet and the one that you're picking up over there are both due and they're going to count as double assignments. So make sure they're both done. See, Noah and Wade ain't going to have a clue. Lay them on my chair.
Said make sure that you get things done.
No, that's not what I said.
I've done it.
So this one and the one you're picking up both count as double assignments. So if you don't do either one of them, 4 0 is what's going to go in the grade book. The other thing, you guys going to listen or we'll wait? The other thing, due next time. Chapter 5 test redos due next time. Quizzes on Moodle. If you haven't done them yet, they close here real soon. I would suggest here in the next hour or two, you get them done.
Won't be home tonight.
Well, I didn't know. I logged on once, but I know it will log out eventually. See what I'm saying?
Logged in myself. What's it gotta have? They gotta start the session. Wait, move time.
That's what he
It's
was.
just like, kind of something, there's no way he's gonna like this anymore.
You know what I mean? David, did you have a question or something?
Why didn't you just put the repeated symbol on top of the one instead of writing it down?
I don't want everybody to see that when you divide by 9, that's what happens. Whatever number is on top of the fraction is the number that's repeated over and over and over again. So if you had 5 over 9 and you were trying to divide it, your answer should come out to be 0.5 with a bunch of 5s.
I just put the repeated symbol at the top because I didn't feel like writing
See,
on
that
that.
didn't help you to see.
Yeah, I know,
What's that?
it'll keep going.
You do me a favor. Close that. And,
I turn this in.
Where's your
Yeah.
pen at? Oh.
Close it and shut.
Where do you want me to put it?
I'm recording all this. You want me to tell you where to put it, Jordan? You really do? Because it's 2:30. I think now I wouldn't get fired if I told you that I wanted to do it.
Right, let's
Start doing your work on time.
It's all right.
Wait, you're talking about this, right?
Yeah, shut it and then pull up,
That thing just happened.
This is not good.
What crap? I don't know what side goes on what side. Does the, how do I do this?
push the indented button, the
Come
concave
here,
button.
back. Come on, off here.
Concave, what's
I
concave?
don't know.
You had it right. Push the concave button.
Is it, which one is it?
Do you want me to keep it?
After school, Eversol?
Discard?
Discard. Now, go down to the filming thing down there at the bottom. It's right by the, right above the rag. Pick that up. Hit the pause button.
My